Hi, in this video we'll be going over AP Calculus's AB free response question number 4 from 2012. So to get started, go ahead and download the question from AP Central. I've provided the URL here in case you don't have that link already. And it's a good idea to try it out for yourself before looking at the solution. This is a good problem because it's fairly straightforward as far as what you're going to do. It's clear that you find the derivative, the equation of the tangent line, and then answer some other questions. So once you've tried it, we're going to go over the solution. You can also download the scoring guidelines from AP Central so that you can see exactly where you get points, but I'm going to go over it in much more detail than the scoring guidelines do. So let's get started. Okay, the first part, part A, just says find f prime of x. We know that's the derivative. So for our function, square root 25 minus x squared, we're going to have to use the chain rule. So the first step is to write it as 25 minus x squared to the 1/2 power. Then when we do the derivative, we get 1/2 times 25 minus x squared to the negative half. And then we have to multiply that by the derivative of the inside. That's where the negative 2x comes in. Second line is just simplifying that derivative. Now you don't have to do that on the free response question. The first line would give you full credit. However, it's a good idea to get in the habit of simplifying because you need to for all the multiple choice questions. So when we simplify, the 2's cancel and we're left with negative x in the numerator, and we write that negative exponent as a positive one in the denominator. So we have square root 25 minus x squared in the denominator. Now, originally the function is only defined on negative 5 to 5, so ideally we include that part as well. For the AP exam, part A was given 2 points. Each free response question is worth 9 points, so that's an easy 2 points as long as you remember the chain rule there. Moving on to part B, this part asked us to write the equation of the tangent line. So you need to find a few things before you write the equation of the tangent line. You'll need the slope, and you'll need the y value of the point. So you can do it in either order, but I found the slope here first. So the slope m is just the derivative at our point, negative 3. So using my information from part A, I plugged in negative 3 to the derivative, and we get 3/4 here. In the next step, I find the y value. So where it has f of negative 3, I'm going to find the y value at negative 3. So I just plug that back into f, and I get 4. My third step, or my final part of this problem, is to find the equation of the tangent line. You can use either y equals mx plus b form, or you can use point slope form. I tend to teach it this way, so I'll use y equals mx plus b, slope intercept form. So I just put the equation there so you remember what we're looking at, and then I plugged in the slope, 3/4 from above, and the x and y value, negative 3, 4. So that all I'm solving for is b. So 4 equals 3/4 times negative 3 plus b, and my final answer, b, is going to be 25/4, and I write the whole solution, y equals 3/4 x plus 25/4. Now if you did it the other way, another equation you could get is y minus 4 equals 3/4 times x plus 3. For the AP exam, they gave 2 points for this part of the question as well. One for finding the derivative at negative 3, that was a key point, find the slope of 3/4, and the second part for the answer. So if you found 3/4 and then didn't quite get the answer correct, you would still get 1 out of 2 points here. Now note, the AP does not give points for incorrect parts, even if you had the right reasoning. If it's incorrect, it's incorrect. Some APs are graded differently, but the AP Calculus exam is based on if the answer is correct along with the method. In part C, we're going to look at continuity. So first, imagine what something that's not continuous would look like as a piecewise function. So here's an example of a non-continuous piecewise function in the drawing. There's a curved piece on the left and there's a straight line piece on the right. But that dotted line between them shows that the pieces don't match up. So there's a gap between the two pieces. This is what you're worried about with piecewise functions. We first look at, are the pieces themselves continuous? Then we look at, do they match up? So let's look at our function. F is a square root function. That's always continuous for the values in the domain. Same with g. G is partly f and partly x plus 7. So the x plus 7 part is continuous because that's a line. Now we just have to determine, do those two pieces match up? So the way we do that is we're going to look at the y values and the limit there. So when the question says use the definition of continuity, that's what we're doing. So first, if I look at g of -3, that tells me I use the top function because I use f of x for -5 to -3. So f of -3 was 4. And then I look at the limit as g is approaching 4 from both sides. So if you look at the second equation at -3, that one is also going to be 4. So by the definition of continuity, since the y value is 4 and the limit is 4 and those are equal, g must be continuous at -3. So you want all three of those conditions to be true. Part D looks at an integral. We're just asked to find the value of this integral, of this definite integral. So this is a u substitution problem, and they're really testing if you know how to do u substitution. So part D is worth 3 points. So I've shown you what u should be equal to on the right side of the equation. So you want to make u 25 minus x squared because the derivative of that, du, is -2x dx. Now in your problem you have x dx. So to make that match up, I'm going to divide both sides by -2. So I get -1/2 du equals x dx. Now it matches my problem, and I can substitute in -1/2 du for the x and dx in the problem. Now note, in the second line here, I've put the -1/2 outside the integral. You can always put a constant inside or outside of the integral. It can help visually to put it outside because now all I have to focus on is integrating square root of u. I don't have to worry about the constant being in the way. Hey, again, it's legitimate either way to do it. So square root of u is really u to the 1/2. So when I take the integral of that, I get 2/3 u to the 3/2 power. I still have that -1/2 out in front. So we're going to multiply the -1/2 and the 2/3 together. Now I dropped the 0 and 5 from the integral just because it's technically not correct to keep them if I do a u substitution because those values are technically different. Now I'm going to do this by integrating, plugging back in for u, and then plugging in 0 and 5. So those will come up again later. So in the fourth step here, I'm going to plug back in for u. U is 25 minus x squared. So I just put that directly back into the equation. And I simplified the 1/2 times 2/3 to just be 1/3 there. So -1/3, 25 minus x squared to the 3/2 is where I'm at. Now I'm going to plug in the 0 and 5. I want to evaluate it from 0 to 5. So my next to last step has the 0 and 5 plugged in. And then our final answer is 125/3. Now you'll notice this is not a calculator question, so you do have to calculate the 25 to the 3/2 part by hand. If you've forgotten how to do that, what you want to think about is 25 to the 1/2 and then cubed. So I think, what's the square root of 25? That's 5. And then I think 5 cubed, that's 125. So that's how you do that kind of thing by hand. Those little exponent things tend to pop up in a few places on the AP, so go ahead and review those if you're not sure. So that was question number 4. If you have any additional questions on this, always feel free to contact me.